At the edge of a black hole, if you turn back, you would see 100 copies of your own silhouette. This isn't magic, it's the photon sphere. 15 seconds later, even light cannot escape your eyes. Today, we're tackling a brutal question. What would really happen if we threw you into a black hole? And this time, we're not talking science fiction. This is based on hardcore theoretical physics. But before tossing you in, let's take a quick look at what a black hole actually is. Even Einstein himself once described black holes as the place where God divides by zero. He didn't even believe such objects could truly exist in our universe. Yet, humans eventually found them. When extremely massive and dense stars reach the end of their lives, they collapse completely, leaving nothing behind. What they create is called a singularity, a mysterious point in spacetime said to have infinite density, and therefore infinite gravity. General relativity introduced a revolutionary idea. Gravity isn't really a force acting on objects. It's simply the curvature of spacetime caused by mass. This explains perfectly why Earth orbits the Sun, and why each planet moves around its home in space. Inside a black hole, there is no solid black surface. The singularity hidden within is just so dense that it warps space-time violently, forming a deep well with vertical walls. In 1939, Einstein even published a paper insisting that stellar collapse into a singularity was unrealistic and would not occur in our universe. Ironically, that same year, Oppenheimer, yes, that Oppenheimer, and physicist Hartland Snyder published a paper predicting that stars could indeed collapse into black holes under their own gravity. Now, let's talk about what happens if you fall into one. The most astonishing thing about black holes is this: anything can become one. Stars, planets, or tiny humans like us. Compress any of them to within their Schwarzschild radius, and they turn into a black hole. German physicist Carl Schwarzschild was the first to find the exact solution to Einstein's field equations. The discovery was both simple and beautiful. Take our sun, for example. If you compress it into a sphere just 3 kilometers wide, boom, you get a black hole. And Earth. It would become a sphere with a radius of about 9 millimeters, roughly the size of a marble. For a human to become a black hole, we'd have to be compressed to a size far smaller than a proton. Absurdly tiny. But if we could shrink that much, we'd become a black hole too. So, which black hole should we throw you into? We could pick a small one, but that's boring. Let's go big. Some black holes are larger than our entire solar system, with billions of solar masses. But that's a bit overkill. Let's choose something closer to home. Sagittarius A*, the supermassive black hole at the center of our Milky Way. You're literally orbiting it right now. It's also one of only 2 black holes humans have ever imaged directly. Now let's set the scene. Imagine you and I fly there together, parking our spacecraft a trillion meters from the event horizon. We're sending you down, while I stay on the ship observing everything. Here's where things get interesting. General relativity tells us that time near a black hole is experienced completely differently, because space-time is so severely distorted. Interstellar showed this effect beautifully. To track this difference, I give you a special watch that displays 2 times the time from your perspective and the time from mine on the spacecraft. We sync the watches. Your journey begins. At first, you see matter swirling into the black hole. A spectacular sight. Friction heats this material to extreme temperatures. Simulating this scene on a normal laptop would take more than a decade. In reality, the accretion disk would glow bright blue or even white. But in this simulation, it's shown in orange, just to make things easier to see. You check your watch for the first time. Only 30 minutes have passed. Yet you've completed just 0.1% of the journey to the event horizon. So far, I'm only 11 seconds ahead of you. Nothing too dramatic. But now we're closer. The curvature of spacetime is creating bizarre visual distortions. Light from the sides, even from behind the black hole, is bent into your eyes. You check the time again. 2 hours have passed for you, and you've traveled 1.4% of the way. Meanwhile, I'm 44 seconds ahead. The black hole's shadow, the dark region in the center, is growing faster than expected because gravitational lensing bends light that would normally pass by you and sends it straight into your retinas. After another long stretch, you check your watch again, and this time it shocks both of us. 12 hours have passed for you. But for me, on the spacecraft, I've been watching your fall for almost 15.5 hours. We're now extremely close to the black hole. Things are about to get strange. Before reaching the point of no return, you encounter an astonishing region. If time were frozen for you here, and you looked around, the sight would overwhelm you. You've reached the photon sphere, one of the strangest places known to physics. Here, gravity is just strong enough to force photons into orbit around the black hole. It's not matter emitting or reflecting light. It's the light itself trapped in orbit. If a beam of light moves tangentially to the black hole, it can circle it. But if its path shifts even slightly, it either falls in or escapes into space. In these conditions, if you were frozen in place here and looked around, you would see the back of your own head, multiple copies of it, staring into space. You're literally seeing yourself, as if you were standing beside yourself, in real time, without any technology. Just space-time, twisted to its limits. You continue your descent, and the event horizon now dominates your vision. Darkness seems to swallow you. Not because it's empty, but because space-time is bending the black hole's far side and edges into your line of sight. You've been falling for 13 hours. In 24 minutes, you will cross the event horizon. But from my perspective, I've been watching your journey for nearly 20 hours. 18 minutes later, you check your watch again. Now I have observed you for almost 40 hours. Your final 18 minutes, last 18 hours for me. And now, the moment arrives. In 6 minutes, you will cross the event horizon. You close your eyes, take a deep breath, check your watch. It appears broken. It says, I have watched you fall for an infinite amount of time. But it isn't broken. This is physics. From my perspective, I spend decades watching you creep closer to the horizon. Eventually, your image becomes redshifted. So much so that I need an infrared telescope to see you. I will never see you cross the event horizon. Even if I lived forever, your last 6 minutes become my eternity. It sounds like science fiction, like a dream. But it comes straight from Einstein's equations. Now, you're inside the event horizon. What happens next? Strangely, you can't tell the exact moment you crossed it. You can still look outward, see distant stars, even see our spacecraft drifting in space. But all that light, like you, must now move inevitably toward the singularity. You've passed the point of no return. A place of infinite density, where physics itself breaks down, and time comes to a stop. To escape its gravity, you'd need to move faster than light, which is impossible. A common misconception says that looking outward from inside a black hole would let you witness the entire future of the universe at once. But that's not true. As you approach the singularity, the outside universe compresses into a narrow, glowing ring. Finally, as you get close enough, your feet stretch forward first, your body elongates, and you are spaghettified, pulled apart atom by atom. You merge with the black hole, becoming part of its mass, drifting through the universe for eternity. The entire process is terrifying to imagine, yet impossible not to wonder about. Black holes, these mysterious cosmic monsters, are something we both fear and can't stop being fascinated by. If this journey into the heart of a black hole sparked even a flicker of wonder in you, then imagine what else awaits beyond the next star. Here on Interstellar Whispers, every story pulls you a little closer to the mysteries that shape our universe and maybe even reshape you. So, if you felt that tug of curiosity, don't let it fade into the cosmic background. Hit like, subscribe to Interstellar Whispers, and share this video with someone who loves asking impossible questions. Because, together, we're not just watching the universe, we're listening to its whispers.